In this lesson, we're going to look at the more robust merge sort. Merge sort works by splitting up the array into individual pieces, as you can see in the animation in front of you. Then it compares adjacent elements and puts them in order. So notice now the 8 and the 7 will be swapped, and the 2 and the 4 will stay in place. Next, it looks at adjacent elements of each pair and then orders those. So now we have 1, 3, 5, 6, and we'll have 2, 4, 7, 8. And then finally, both parts are merged and sorted into the final correct order. Notice that each half is in order, so it's just a matter of taking one from each pair, sometimes two, and then putting them into place. All right, so let's see how we would implement the merge sort algorithm. We're going to call our program mergesort.java. I'm going to take the beginnings of the bubble sort program. First, let's change its name to merge sort. And then let's get rid of any code that represents either the insertion sort right here, we'll get rid of that, or the bubble sort call right there. Okay. The other thing we're going to do is we're not going to create our array from random numbers. So we're going to delete that section. We're going to assign our array with an initialization list. So let me do that real quick. Okay. Another thing we have to do before we implement the algorithm is set the values for the lower bound of the array 0 and the high or upper bound, which is 9. We'll see how that works in a minute. Now let's get into the actual merge sort algorithm itself. So we're going to write two methods. The first one is called merge sort. It's the main method, but it's going to use a helper method also. The first thing we do is create a variable size that holds the array's length. Then we make sure that low is less than high. And if it is, then we compute a middle value, which we'll use to split the array into two. And then we're going to call merge sort with the lower half. That's this one. And then call it with the upper half, like so. Then we call a helper method merge to do most of the actual work. And that's it. The merge method is a little more complex, as you'll see. First thing we do is we create a temporary array. Go back and compute the size again. Then we're going to initialize the temp array. And we need three variables to represent the low, the position right past the middle, and then we need the low value again in K. We'll call it right there. Now we're ready to loop through the data and sort it. That's what we'll be doing right here. I won't be doing a lot of talking here because I need to concentrate on my typing. So please bear with me. So what we're doing is we're using the temporary array as a placeholder to sort out the data, so to speak. And then once we have it in the order that we want, then we put it back into the regular array, which is ARR. So that's what I'm doing right here in these lines. And we have one more while loop. This is the final loop that pulls everything together. Increment K, and then increment I. Close the while. Close the method. Go back to our program. Here's where we would have the merge sort call. So we'll call it merge sort with data, low, high. And remember that low and high represent the lower bound of the array 0 and the upper bound 9. So now let's save our code. Back to our command prompt, clear the screen, compile, and then run. And there's our original array, and there's our sorted array. In the exercises, we'll try this with a larger data set because we're going to do some timing experiments. And we'll see how much faster merge sort is than, say, insertion sort or bubble sort. So we'll come back and look at this algorithm again in the exercises. But for now, I'm ready to move on to another lesson where we're going to look at another robust sorting algorithm, the quicksort.